Likelihood is model dependent, and it matters which model we select. So how do we select among a virtually infinite universe of models? It turns out that we can use likelihood itself to calculate the best model. And let me use an example from dice rolling to show you what I mean. I have 10 dice here, and I'm gonna roll them out on the table and see what I get. All ones. This looks pretty improbable. What's going on? I got 10 ones. What is the probability of that? One in 60 billion. Let me try that again. Again? Now I'm starting to get suspicious. What's happening here? Are you surprised by that? In other words, if likelihood tells us how surprised we are by the data, are you surprised that I could roll 10 dice and get all ones twice in a row? That's 60 billion squared. Let's see what's going on here. Well, it turns out that it depends on the model we've selected for dice. What was your original die model? Was it a 6-sided die with 6 different numbers on each side? That's the usual model we have for die. And that would make the probability of landing on all ones 1 in 60 billion. But what if all 6 sides had a 1? That's a different model. And the thing is, we could use likelihood to select among those two. With the first roll, we could ask, I'm going to select between 2 different models, 2 discrete models. One would be a 6-sided die with 6 different numbers on each side, and the other would be a 6-sided trick die with all ones. Then I could ask you, which of the 2 models is more likely? It's fairly simple. So, selecting among models is similar in using likelihood. We can't select among an infinite amount of models, but we can compare one model with another and ask the question, which of these 2 models better fits the data?